Lecture 9, Equations of Value. In this lecture, we're going to talk about balancing two opposing flows of money. And we refer to this process as equations of value. Equations of value gives the equivalent values of opposing flows of monies, such as debts versus payments, according to a specified interest rate. These values are determined on a comparison date, what we refer to as a focal date. It determines the equivalent sum of money with consideration to interest. Essentially, what we're looking at is inflows equaling outflows when we consider interest. And hopefully this will make more sense in a few minutes after we do a couple of examples. So let's jump to one. Example 1, you bought $80,000 worth of manufacturing equipment. You financed the purchase at 12% compounded monthly. Consider the 4 different scenarios for paying for the equipment over 2 years. And so we have 4 different scenarios laid out here, A, B, C, and D. Different ways that we could pay for the $80,000 worth of equipment. Now, before getting into any of these scenarios, I want to make sure that we're clear on the story preceding the scenarios. So we bought $80,000 worth of manufacturing equipment, and that's the beginning of our story. So I'm going to draw a timeline. We're going to use timelines a lot when doing equations of value. So this is the beginning of the story, $80,000. And we essentially bought that equipment, but we still haven't paid for it. So we're receiving $80,000 worth of equipment. So I would call that an inflow because you're receiving $80,000 worth of something, though we haven't paid for it. So that would be the opposite outflow, the payment for that. $80,000 worth of merchandise, that becomes our inflow, what we're receiving. It would be a debt. Outflow, our payment is opposing direction of money, paying for that. Now the next piece of information we were given is that interest is being considered at 12% compounded monthly. That's what the interest rate is for the financing of this debt. So I would write that as J12, the subscript 12, because we're compounding monthly, and the nominal interest rate is 12%. I would then be able to calculate the applied interest rate. It's going to be 12% divided by 12 periods in a year, or 1%. And finally, we know that this story is going to take place over 2 years. Each of these scenarios for paying the equipment are over 2 years. So I can write the last date on my timeline right here. So now that we have a clear idea of this preliminary information, let's look at the first scenario, scenario A. Each of the scenarios informs us how we are going to pay for the $80,000 worth of equipment. So in this scenario A, we pay $0 initially, and then we agree to pay off the debt in 2 years. Just paying one simple payment in 2 years. How much do you have to pay in 2 years given the financing rate of 12% compounded monthly? So pay the debt off in 2 years. That amount of money will be at this point in time. And this is what we were doing in lecture 8. So I calculate the future value of that $80,000 over 24 compounding periods, because we have 2 years and 12 compounds per year. And when I put that into our equation, PV times 1 plus the applied interest rate to the power of n, I get $101,578.77. So that becomes my future value for this problem. That is how much we would have to pay in 2 years. But here I want to emphasize that we are going to consider these values, $80,000 and $101,578, to be equivalent. We consider them equivalent when we consider the addition of interest that's accrued over that time period. So that $80,000 we would consider to be equivalent, have equivalent value to the $101,578.77 at a different time after 2 years of interest has been accrued. Now let's look at scenario B. You paid $5,000 immediately, and then you agreed to pay the remaining debt off in 2 years. How much do you have to pay in 2 years? So now we have two payments in this scenario. The first one is an immediate $5,000 paid right here, and the other one is going to be the remaining debt in 2 years. How do we do this analysis? So here I'm trying to determine this amount of money at 2 years. In the previous question, or scenario I should say, we moved the $80,000 into the future to calculate what that value was. But that's not going to work this time because I have this $5,000 initial payment. It's not like I'm going to pay the interest that's related to the full $80,000. Instead, what I'm going to do is I'm going to calculate the net amount at this point. Now, because they're at the same point in time, I just take the difference, or I add up the values, and because they're in opposing directions, I would take the difference. And then I find the future value of that net value. Essentially, we left the manufacturers with $75,000 of debt, and we're seeing the additional interest that gets added to that over the 2 years. And I calculate that future value based on our relationship here over the 24 compounding periods that occur over 2 years. And I get my future value of $95,230.10. So in scenario B, what we really have learned is how to handle that down payment, or how to handle two payments on the same day. We would take the net amount of money. And in this case, we would also consider $75,000 at year 0, the amount of debt that they left the manufacturing company with, is equal to $95,230.10 at year 2 when we consider the additional interest. Let's look at scenario C. So you paid $5,000 immediately, you arranged to pay an additional $24,000 in 6 months and the remainder of the debt in 2 years. How much do you have to pay in 2 years? So $5,000 is immediately paid, that's right here, and that leaves a net of $75,000 at point 0 on our timeline. And then we have our $24,000 that gets paid in 6 months. So I draw half a year later, because that's 6 months. There's the $24,000 payment, and I put that on the payment side of my timeline. And then the remainder of the debt is being paid in 2 years. I'm going to put that at the 2-year mark, and that's what we're trying to solve for. So now this is when this sort of problem gets a little bit more complicated. We're going to start to enter a more formal process. It's the same process we were using in the previous scenarios, but I'm going to add in some formalized structure to it. So when we have a problem where we have multiple time periods and we're trying to get that equivalent value, that balancing of our outflows to be equal to our inflows, we first draw our timeline. Then we determine what our flows of money are. In this case, we have a debt and payment situation. I'm going to draw all my payments on one side of my timeline and all my debts on the other side of the timeline. So all of that has already been done. Then what I do, I select what we refer to as a focal date, a date where we're going to move all of the money to. Basically, we're going to get the equivalent version of each one of these amounts of money on one date so that we can start to look at balancing on that date. So I recommend that we select a focal date that is associated with something that is unknown. In this case, we have one unknown payment right here. That's often a good place to select a focal date to make your analysis a little bit easier. So I select that focal date and I draw that right here. You can see that blue circle right there. That's my focal date. And what I'm going to do is I'm going to move my money to that focal date. So I'm going to move my $75,000 to that focal date, essentially moving it into the future so that I get the future value as it moves forward in 2 years. we would say that it accrues that 2 years or 24 compounding periods worth of interest, bringing it up to $95,230.10. And this value I know from Part B. Now, this isn't how much you're going to pay at 2 years, because we also have this $24,000 payment. So to consider that $24,000, I also move that to the 2-year mark, moving it forward 1.5 years to get to the 2-year mark, or 18 compounding periods where it would be accruing interest. So I calculate the future value of that $24,000. It's going to be that principal times 1 plus the applied interest of 1% to the power of 18. And I get $28,707.34. So I'm going to add that amount of money right here. So now all of my monies, you can see the $75,000, I have the equivalent value at 2 years when interest is considered. The $24,000, I have the equivalent value at 2 years when interest is added. And I have this lump sum of money as well, though it doesn't have interest added to it because it's at 2 years. So now I'm going to add up all of these monies that I've moved to the 2-year mark. It's all of the money that's been in the story once we consider the interest that would be added to them. Now I'm going to blow that up on our next slide right here, so I can see my outflows would be the $28,707.34. That's a future value of the $24,000 plus the amount paid on 2 years. Then we have the inflows, the debts of the future value of $75,000, $95,230.10. Now, for these to be balanced, what we need to happen is our debts to be equal to our payments when interest is considered. And interest has been considered already. So I take the $95,230.10 debt. It will be equal to the $24,000 payment, which became $28,707, plus the amount paid on 2 years. And from here, I just do some algebra. So I'm going to subtract $28,707.34 from each side. And I get the amount paid is the difference between $95,230.10 and $28,707.34, which gives me $66,522.56 is the amount that would have to be paid at the 2-year mark. So this is how we handle equations of value. When we have those multiple payments going on, we really need to solidify a process for this. So when you compare the inflow and the outflow, you do so on the same focal date, i.e. we compare money at the exact same date. And in this example, that was at year 2, the time period when money was being paid back, or the second installment. After we adjust monies for interest at that focal date, the inflows and the outflows should be equivalent. They should balance each other out. We have a general approach to equations of value that you can kind of anchor yourself with. First, you would draw a time diagram. Second, you identify the transaction types. What's going to be your inflow, your outflow? Sometimes we would say the old versus the new payment structures. Then we would put those inflows and outflows, those monies, the actual dollars, on the opposite sides of the timelines at the point in time that they're associated with. We would then circle the focal date. That's going to be our date of comparison. And then we would move all of our money to the focal date by adding or subtracting the interest that is based on the time difference with the focal date. And that would be using one of these two equations. If we're moving money forward, we would calculate the future value. If we're moving money backwards, we would calculate the past value. Finally, we would balance the two sides of the timeline so that our inflows are equal to our outflows, or our old is equal to our new, depending again on the scenario that we're looking at. Okay, so let's do one more scenario in these slides. You pay $5,000 immediately, and then you arrange to make 2 equal payments, the first in 6 months and the second in 2 years from today. Calculate the size of these payments. Going with our process for equations of value, I'm going to first draw my timeline, which we can see here from 0 to 2 years. And then I'm going to define the transaction types. I note that this is a debt and payment structure where I am getting $80,000 worth of equipment but not paying for it right away, and then I will have to pay for it over the time. So then I write those inflows and those outflows on the timeline, so I can already see I've written my $80,000 right here, and then I'm going to add my $5,000 that I pay immediately right here, which nets to $75,000 at 0.0 on this timeline, or the 0 year mark. Then I have my two equal payments. The first one is going to be in 6 months and the second one in 2 years. And these two payments are equal, so I denoted each one of them as X so that I can keep track of them. X being however much in dollars that gets that the transactions are for, and expecting them to be equal numbers at the end. And I'm going to try to calculate the size of those payments, but first I need to select a focal date. Now, I can select any focal date I want. The date doesn't matter, as long as my analysis is good at moving the money to that date. So I could select a focal date of 0 years, 0.5 years, 2 years. I could even select a focal date of 1 year right here in the middle. However, our analysis is a lot easier if we can limit the number of dollars that we move. So we try to keep it at one of the points where we already have money. This way we don't have to consider interest for that amount. And it's even easier if we select a focal date that's associated with something we're trying to calculate. In this case, one of these payments that we have denoted by X here. I have selected 2 years as my focal date for this story, though again, I could have selected 0.5 years as my focal date and it would have worked out just as well. So next thing, I'm going to move my money to that focal date. I start by moving the $75,000 to that focal date, a calculation I did in part B. So that becomes $95,230.10 when I calculate the future value of $75,000. And then I have my other money, this unknown money, but still I have to move it and consider interest with it. So this is an unknown amount of money, but it is moving 18 compounding periods forward. So I can try to do the calculation with as much of the information as I have. So the future value of X is going to be that unknown PV, principal, times 1 plus the interest rate is going to be the 1% interest rate, and I have 18 compounding periods. So I put that all into the equation. So I have X times 1 plus 0.01 to the power of 18. And when I calculate this part of the equation, I get 1.19147476, and it just fills up my calculator, times X. So I put that X on this side instead. And this becomes a coefficient for the X value. So there is how many times X. I basically get 119% of the X value here, or 1.19147 times X is what it grows to over that 1.5 years where it accrues interest. Now I've moved all of the monies to the focal date. Every single amount of money is at this 2-year mark now when interest is considered. So then I sum up all of the values at that focal date, at that 2-year mark, and I balance out this equation. Again, blowing this up on the next slide. I have my outflows, my inflows, and I'm trying to make them equal. So I have my one value on the debt side, the $75,000 that we calculated the future value of, to be $95,230. And then I have the two payments on the outflow side, which we've calculated the earlier unknown payment to be 1.1947x plus just this 1x right here. And this is really 1x when we look at this. And that's going to help me with my algebra, as what I have here is 1.19 plus 1x, 2.19147x. So from here, I want to isolate what x is, so I can see that it's being multiplied by 2.1914. So I divide both sides by that value. They cancel out on the right-hand side, and I'm left with x is equal to $43,362.34. That is the amount that we would have to pay at both 6 months and 2 years in this scenario.